This is the first lecture of a series on SQL and relational databases. So first off, what's a relational database? Well, a relational database is a special type of database that's used to store a lot of data. So loosely speaking, I'm just going to call a relational database as a collection of interrelated tables. So tables are just data sets. They have a bunch of rows, bunch of columns. Think of a spreadsheet in Excel or a data set in an SPSS or SAS. But a relational database usually consists of more than one table, and these tables all have relationships with each other. So I think we've already seen a lot of examples of relational databases in this class. If you think about the DMEF1 example, there was a customer table that had information, one record for every customer, and gave information about that customer, like the gender and the address. There was another table, which was the transaction table, and that transaction table had a record for every donation that a donor made. There was another table in there that decoded the code, the contribution, the solicitation code. So remember, the solicitations came in about 5 types, and there was some code identifier that then got mapped to one of these 5 types. So there's an example where you have 3 tables. If you think about what we have with air miles, we have a relational database. So we have a transaction table, we have a viewing table, a posting table, a key. All right, so these are interrelated tables. Now, many database systems use this relational format. There are other formats, there are hierarchical databases as well, but by far the most common is one of these relational databases. There is an industry standard language that's used for accessing these these tables, and it's called SQL, which stands for Structured Query Language. So SQL is the same across many different platforms. It doesn't matter if you're using Access or Oracle. So Access sits on top of an SQL engine. DB2 is an IBM mainframe product. Microsoft SQL Server. MySQL is a public domain SQL program, kind of like Firefox. All right, so SQL then is the standard language that's implemented by most relational database systems. So if you know how to speak SQL, you can interface with any of these database systems. You can think about SQL as duplicating a lot of what's already in SAS base. So, in some ways you don't need SQL because you've got the base SAS, which does merges, does prints, does summaries. So in that sense, you don't really need SQL, but it pays to know it just because you don't always have SAS. And so if you're at a company and they have an Access database or an Oracle database, knowing some SQL will get you somewhere, whereas SAS won't if they don't have SAS. There's some different vocabulary depending on which community you're in. So if you're in a data processing community, they use one set of terms. If you're a statistician, especially someone using SAS or SPSS, there's a different set of terms, and then SQL has its own set of terms. So this table kind of maps these terms to each other. So we've been talking a lot about data sets or data files in SAS or SPSS. Data processors call those files. In SQL, those are tables. Likewise, statisticians use the term observation. So we have a sample of n observations, or units would be another term, but I guess the statistical software term would be an observation. Data processing calls it a record. SQL calls it a row. So those 3 things mean the same thing. Likewise, if you think about your table has variables in it. So we talk about age as a variable or income as a variable. SQL, it's going to be called a column. Data processing will be called a field. So what you will probably hear me doing is using these terms interchangeably. So just keep in mind that if I say column, that's the same thing as a variable. If I say field, that's the same thing as a variable. So SQL you can think of as duplicating a lot of the functionality in SAS. So what it does for you is essentially what proc print does, rolled up with a data step, with your merges, with a proc sort, with proc summary. So that's mostly what SQL does. Now there's a few things that SQL does that SAS doesn't do, and we'll be getting into those in the later lectures. But let's start out with doing these tasks that you already know how to do in print, sort, and the data step, merge, all that. So the main command in SQL, the one that you're going to be speaking most, is called the select statement. So if I joke, if you know one sentence of SQL, it will take you a long way. Here is that one sentence. So a select statement may or may not begin with a create table. So if you create table, what that does is it sends the result to a new table. If you omit that, it sends it to the screen. Then you're going to select certain columns from certain tables, and then maybe you want to restrict your cases with the where statement. Maybe you want to do some by group processing with group by. Having restricts the group by processing. I'll illustrate that with an example in a minute. And then maybe you want to sort or order by certain columns. A few things to note. These will drive you crazy, so remember them. So in SAS, all your variables are separated by spaces. So if I said, var x1, age, income, I would separate them by spaces. In SQL, you separate them by commas. And so I always get confused on that, and I'll just put spaces in, and of course SQL then complains. So just like in SAS, if you get a syntax error, you probably forgot your semicolon. In SQL, you probably forgot your commas. A couple other things just to keep in mind. These are real common errors. You do not need to end a select statement with a run statement. If you do, it terminates SQL, and you have to run it again. All right. So if you just have one select statement, no big deal. SAS will give you a little warning message reminding that you don't need a run, but all you need is a semicolon and a select statement. The other thing to remember is you use one semicolon per select statement. So if you look up at my syntax here, it's all one sentence. That sentence ends in a semicolon, and you're done. Okay, so one semicolon per select. I'd now like to just give you a few examples to illustrate the flexibility of this. So what I did was to go back to that little data set, let's make this a little bit bigger, that we've been using in some of our previous lectures. So I read in my data. Now, I'm going to invoke SQL. So if I say proc SQL, that starts up SQL. And let's write the simplest SQL program that I can think of. So here it is, select star from my data, semicolon. The star here, as I indicate in the comment, means give me all the variables. So this is saying give me all the variables from this data set. So if you wanted to translate that into proc print, it would just be proc print data equals my data run. And here's the output you get. It looks a whole lot like proc print, except it doesn't have the observation numbers. Now sometimes you don't want to print all the variables. In fact, most of the time you don't. So how could I restrict what I print to just certain columns? Well, the answer is you list some variables after select. So instead of saying select star, just list the variables that you want. So select color, here we go, comma, X. It means just give me those two columns from my data. And then just to show you some of these other options, we're going to order by X descending. So what that means is sort the data set first by X descending. So if you look at the output, values of X go 5, 3, 1 in descending order. And then just give me color in X. So this is really pretty convenient. If you think about translating this into SAS, you would have to say first proc sort, data equals my data, by descending X, semicolon run. Then you'd have to do a proc print with a var statement selecting just color in X. So it's a little bit more parsimonious in terms of the amount of that you have to code. All right. Now let's make this slightly more complicated. So I'll walk you through my code. We're going to pick color in X again from my data. This time I'm going to restrict which cases I show. So let's only show cases where X is greater than 2. And then you'll see if in the output it suppresses that one row where X was equal to 1. So it looks like that where statement is working. Order by 2. So what does order by 2 mean? Well, order by 2 means order by the second variable. So that second variable is X. So what you're going to see is this time it's sorted in ascending order of X, so 3 then 5. Here's another difference between SAS and SQL that drives me crazy. So with proc sort, you say by descending X, you put the descending before the variable. In SQL, it's the opposite. You just have to remember it. I'm sorry. So that's why it was X descending up here instead of descending X the way you might be used to it in proc SAS. So just get used to it. It's another really common mistake that I make. I end up putting descending in the wrong place. Let me get into some conditional operators that you might want to know about, and I'll give you some more later. So the thing about SAS SQL is that it conforms to the SQL standard. So there's a standard SQL that all implementations, whether it's Microsoft's or MySQL or IBM's implementation, follow. So they use certain terms. SAS SQL adds some additional terms to that don't conform to standard SQL. So you can use either terms that you already know from base SAS, or you can use the SQL version. So for example, if you said select star from customer where age not equal dot, what that would mean is pick all the records, so all variables from this dataset customer, and only print those where age is not equal to missing. An alternative way is to say where age caret equals. Caret equals is another way to say not equal. Now this is more traditional SAS where dot means missing. The SQL way would be to say this, not, and then in parentheses, age is missing. Is missing is a keyword. You can also say not age is null. So any of those work. Just pick the one that you like. Likewise with greater than, you can do age greater than 40 with the greater than symbol, or you can say GT, which is short for greater than, just as you can in base SAS or any where statement that you attach to a proc. Greater than or equal is again greater than or equal, or GE. What about ranges of values? Well, the SAS way would be to say something like this. Age less than or equal to, so 40 less than or equal to age less than or equal to 50. Alternatively, you could say where age greater than or equal to 40 and age less than or equal to 50. The SQL way is to write this, where age between 40 and 50. So between and are both SQL reserved words. So any of those work, pick the one that you like. I mention all the versions just because if you're working on a different implementation of SQL, So if you're out at a company and all you have is Oracle, Oracle may not accept something like this. I've not used Oracle, but it may not accept that. I would probably gravitate towards the more standard SQL expression, especially if I were getting syntax errors from Oracle.